This is StarTalk. I'm your host, Neil deGrasse Tyson, your personal astrophysicist. And for today's edition, it's Cosmic Queries Potpourri. And I've got Eugene Mirman visiting in from Boston. Used to be local, and now you're not anymore.
I know.
Why?
You
got married, got kids and stuff?
Got married, children, moved to Massachusetts.
Yeah, that happens.
Yeah.
That happens. Well, welcome back.
Thank you.
We're here in the YouTube studios. I don't know why, but that's where we are. Lindsay, why are we in the YouTube studio?
We're collaborating.
We're collaborating with YouTube. Well, how do we know that? Because Matt O'Dowd is here, in from Australia. That's your home motherland?
Well, Australia once upon a time.
Once upon a time. And we've got you now. You're a professor of physics and astronomy.
Happy to be got.
at the City University of New York.
That's right.
Lehman College up in the Bronx, where I'm from.
Hey.
And you're here because you have a YouTube channel.
I do, yeah.
And it's part of the PBS universe. I'm very delighted to learn that PBS has, a digital studio.
Exactly.
And your program within that is called
Space Time?
Thank you, Eugene. Fan. So Space Time, it's a PBS Digital Studios show.
And these are short, so like 4 or 5 minutes each, or what?
We go a little over. We tend to go 8 to 10.
Ooh.
Can people
I'm kind of a
that?
Yeah, I know.
I feel like that people take naps partway through, but they wake up for the end where the jokes are.
No, that's great. So that's why we've got you here. That's why we're in the YouTube studios. And you're here to help me handle these cosmic queries solicited from the internet.
I got you back.
From our social media base. They get solicited, and sometimes we solicit by topic, and then some don't fit in exactly right, and so we put them all in the grab bag. And so, Eugene,
let's do it.
We haven't seen these, and so the two of us we'll work. We'll work at this.
Okay,
all right?
this is where we prove whether we have anything up here at all.
Go for it.
So let's do this. Jordan Thompson from Indianapolis asks, Neil, there once were reptilian the size of buildings, planets made of diamonds, stars 5 billion times that of our sun, and holes that lead to nowhere. Do you think the universe has any limitations within creation?
So many things to pick on.
Well, first, let me just start off by saying I'm from New York City.
Yeah.
There are no reptiles the size of buildings. Okay, I don't know where he's from.
This feels like Iron Maiden lyrics.
I want to live in this universe, actually.
Yeah, were there ever planets made of diamonds?
Planets,
there still are.
Yeah. So tell us about that. What do you know of it?
So a diamond is a very, very dense form of carbon. Put carbon under a lot of pressure, and those little atoms all align into that beautiful diamond lattice that we like to wear on our fingers sometimes. But planets
crystal
can be...
lattice, yeah.
Crystal lattice, exactly, yeah. Planets are sometimes massive enough that the interiors can presumably crystallize carbon.
And carbon's not rare in the universe.
No. So there are planets, the whole planet.
In fact, there's sections of the universe where it's mostly carbon. There are places where stars in their effluences will actually release copious amounts of carbon.
It's a super common material.
Yeah.
So, I mean, the planets would be, the diamond would be inside. You need to get that pressure. And so you need a bunch of stuff on top so there'd be carbon outside.
I knew it.
You got to dig for it.
Planets.
What? Not all carbon, not all diamond. And the other thing is diamonds aren't that rare anyway, even on Earth. I think we,
idolize them too much.
Yeah, I mean, they're not that uncommon.
Wait, cool. So we got the diamond, and like I said, in New York City, there are no reptiles the size of buildings. But if you live in a small town, T-Rex would be bigger than your house.
Although,
could be.
I know you know this because I think you assembled the T-Rex skeleton yourself at the museum, didn't you? I don't know.
It was a kit.
Yeah,
put it together.
Exactly. Well, so reptiles descended from the same ancestor as dinosaurs, but dinosaurs themselves...
I mean, modern reptiles,
were not reptiles, as far as I understand. They are basically closely related to birds. In fact, birds are dinosaurs, really.
Aren't birds more closely related to the dinosaurs than modern reptiles are?
My understanding, really from the phylogenetic tree at the American Museum of Natural History, is that birds and dinosaurs are really the same thing. birds are the only
Yeah, no,
surviving.
my issue was the reptiles. That's what I'm saying. So everyone's talking about birds being the descendants of dinosaurs without mentioning the crocodile. And is that true? Is it part of, I don't know.
Crocodile is the worst bird.
It is, yeah. It's,
Famously terrible bird.
Neither of us is a paleobiologist. But so all I can say is, there were never dinosaurs the size of New York City buildings. That's all I'm saying.
Right.
and all I want to say is there a limit to this universe? I would say absolutely yes, in that not everything that can exist does, but so many things.
Wait, how do you know that?
It's an educated guess. I think
What
the
about
laws.
parallel-
Name something that can exist that you think doesn't.
Name something that can exist. Well, for example, the mathematics of relativity describe things like wormholes and quantum mechanics says it's tachyons.
You're saying Star Trek isn't real? Wait. Like if I can't emit a tachyon pulse?
I would say an infinite universe contains an infinite number of things, but it doesn't contain everything that you can imagine. I said the laws of physics still have to be obeyed.
So I'm with you on that. So you're not going to have an Empire State Building sized reptile.
Exactly.
Because it can't hold itself up.
Exactly.
With a very interesting. So you know about this? They teach this. I don't know if they teach this outside of like Physics 101. But
Right.
So as you get bigger,
Yeah.
your volume grows. Your weight goes up according to your volume.
Yeah,
But the strength of your limbs goes up only according to the cross-sectional area. So it's a matter of area versus volume.
So Godzilla
would collapse under his own weight into a puddle of
Goo.
guts. Yes, correct.
even
be
if it was
bedridden at least.
irradiated, just because.
Oh, he was irradiated.
Is that helpful? Does that help?
that changes the volume area thing completely.
Right. And
Does it affect it at all?
So
No.
it's why big animals, heavy animals, have thicker legs. So you can't just scale up an insect
Right.
and make them this big, because their body
That
weight.
is great news.
That's good.
First of all, that is very good.
Yeah, and it completely negates half the horror movies of the 1950s.
Wait, so if an ant
That
was
would have-
gigantic, it would.
That would have to be a lot stubbier. They would have to have
Yeah.
serious cankles to be able to.
So as the ant gets bigger, the body weight grows faster than the strength of its spindly legs can support it, and it would just collapse under its own weight. So you can't just scale up insects and get big insects. It's just not going to happen.
Well, I'm going to remove that as a fear I had.
So the laws of physics prevent that, which is why you can't have Godzilla
Right.
as big as Godzilla
How big
is.
could a person be? Like, could you have a giant person that's the size of a building?
A small.
No. I'm talking about any kind of life. I mean,
Any kind of life.
Right. Plus,
So we don't need to fear like giant elephants or King Kong.
Plus, there's another thing that involves blood pressure.
Uh-huh.
Okay? So if you're really, really big
Yeah.
and you have to get blood to your brain, if
Yeah.
your brain is at the top, you would need a seriously pumping valves to do this.
Well, if you had a heart though that was the size of a house inside your body, that's the size of a skyscraper, would that be fine?
You mean that could pump with that kind of energy? Yeah, I guess so. I mean,
Well, you
Yeah,
could maybe
it's just-
so you need maybe 2 or 3 hearts, is what we're saying. If you wanted to be the size
he's
of the Empire
inventing the
State
creature
Building.
here. But
I'm just adding a heart to a giant thing that doesn't exist. I think that's fair.
I think part of the problem is these things evolved from smaller versions, and so they have to kind of co-opt those miniature organs to something that works on the large scale.
they didn't come out of the box big.
Yeah,
right,
exactly.
Right. That's
So
a
the
good point.
biggest creature that ever existed is how like
It's
so.
it is the blue whale that exists today.
Great.
So what's fascinating to me
Yeah.
is that mammals have some of the widest size range of any branch in the tree of life.
What is the smallest mammal?
It's like this big. There's a little.
It's a
You could really- you could eat it.
or a-
For sure.
Pop
like
it in.
as an hors d'oeuvre, yeah.
But you go from this to the blue whale. Now here's where the blue whale cheats. You look up blue whale in the book.
Yeah.
It says blue whale weighs 4 gazillion tons.
Yeah.
Not really.
Because gazillion isn't a number?
Well, no, because not only for that reason, but it's actually floating in water.
Right, it's cheating.
It is
Yeah.
not holding up that weight. And so once you are in water, then there is no limit to your mass.
Wait, so could Godzilla exist but only in water?
Godzilla loves being in the water.
Exactly.
And he could then exist. So it's the
But he couldn't have come out of the water and start terrorizing the town. In the same way, a crocodile is basically useless on the ground. A crocodile has to do a push-up just to walk and then go back down because his legs are not directly under it, which is a big evolutionary advance. I don't need muscles to hold up my body weight because vertically I'm just supported.
So to redo this, Godzilla can exist, but not out of the water.
So it has to go into the water. That's right, and that's why huge, clumsy things can be highly nimble swimming in the water.
Like giant squids or jellyfish would just be a sack of meat.
Exactly.
Yeah.
Exactly.
Okay, great.
All right.
We learned a lot. Thanks.
And that was from whom?
That was from Jordan Thompson.
Thanks, Jordan.
Yeah. Susan.
Was that a Patreon question?
No, it was Instagram.
Okay.
These are all sort of largely Facebook and Instagram. So this one's from
We're
Facebook.
supposed to read Patreon questions first because they
sense.
give us money and they bribe us to read their questions.
First of all, I'm totally with you, excluding the part where I have no questions from Patreon.
Okay.
So I can make them up.
Okay. All right, go on.
If that's
So
it.
that's how you can bribe us.
Yeah.
Okay.
No, I agree. Susan Minobe from Facebook asks, how sure are we about our map of our galaxy and the universe in general? Could our tools, techniques be mapping an illusion and that the universe is much smaller or larger than we've calculated?
Okay. Your show is called Space Time.
Yeah.
So why don't you take
Is
this
everything
one?
we know based on lies?
I mean, it could just be that there's a giant dome that's painted kind of like the Wizard of Oz set.
Right.
And
Are we in a super complicated Truman Show?
I think the closest thing to that is the idea of the holographic universe, where you have this vastly distant shell that's a hologram and that our 3 dimensions are projected from 2. Highly hypothetical, I'm not even going to say theoretical. So all right, how do we measure this stuff? With many scientists working independently, making measurements independently, and getting agreed upon results. In the case of the map of our universe, it's pointing multiple different telescopes at distant galaxies and basically calculating redshifts and but also getting distances by different independent methods.
So I would add that we use a regular telescope that is sensitive to visible light, and that's the extension of our retina, and we see a galaxy there. Now somebody else invents an infrared telescope, or a microwave telescope, or a radio telescope, and we scan the sky, we find the same object, but now emitting in these other bands. So this gives us confidence that the object is real, that it's actually there, and some interesting things are happening in it. And that it's not, and then like as you were saying, before I interrupted you, that you can get the distance to this object by multiple ways. They're not standard ways you would measure distances on Earth. On Earth you can pace out the distance, you could get a little tape measure, you can use now one of these
Like a wheel?
Laser
thingies.
Yes.
So there are multiple ways. If you get the same answer from all those ways, and all those ways are completely different from one another, you have confidence you have the right distance to the object. And so this, you combine all of these factors, we think the universe is real. And it is what we measure it to be. But you can take a deeper philosophical point that there is no reality beyond the measurement. The measurement becomes the reality of the universe that we describe. So to say it really is this other thing, you're just not measuring it to be. So I'll say, how will you ever know that it's this other thing?
Well, I don't know. The question wouldn't be that it's another thing. It's just that we are wrong.
How would you know that we're wrong? We learned in quantum physics.
You learn in quantum physics.
the reality of the world only makes sense through the measurement.
Right.
In a sense,
in a sense. So you cannot. It doesn't mean anything to talk about a world that is outside of a measurement.
So that's what Niels Bohr would say.
Access to it.
I think others. For example, David Bohm and realists would argue otherwise. I think the important thing is not to confuse, though, the idea that we have a subjective experience of the universe, and that subjective experience isn't the universe. It's a different thing to the actual universe, but nonetheless, the universe remains consistent. Our subjective experience of the universe matches other people's subjective experience. We can all make measurements that agree with each other. And that gives us confidence that there is something objectively real out there, even if we can't say exactly what it is.
And I would add to that, but I'll tie a bow on it, that I look at something and I say, okay, that looks red to me. Well, am I on drugs or not? Okay, so that would be a subjective reality. So then you devise an experiment, so you have an apparatus that measures wavelengths of light, and you've already calibrated it to that this wavelength is a red over here. So now you come to this, and the machine measures red as well.
Is the machine on drugs?
You got to teach the machine what red means first.
We have to teach it over here what red is, and then we look at this thing that I'm looking at, and so now we both query the machine, what color is this? And the machine gives us the same answer. So I've removed my own brain from this experiment, and I'm getting the same answer. So to a limit, our subjective experience is reality, but we know the limits of our subjective experience. And the whole point of science is to probe reality, reducing our subjective interpretation by as much as is humanly possible, ideally to zero.
Yeah, or refining the subjective model so that it better and better predicts the objective reality, even though it will never be the objective reality. It's a highly effective predictive, apparatus.
Okay.
All right.
Next question.
I think we have time for like one more question in this segment. All right, what do you got?
From Leo Zusa on Instagram. How about the recent articles about the possibility of us being part of a simulation and the Big Bang being just the seeding event of such simulation? Thanks.
I'm totally there.
Yeah.
I'm digging it every minute of it. You don't like it? I'm loving it.
I want to hear your opinion.
I'm loving it.
I want to hear this.
I'm loving it.
Well,
So who made the simulation?
Some snot-nosed kid in the parents' basement of an alien civilization who's bored and they're more advanced than we are, and they have way more computing power than we are.
Right, so it's like a little handheld Nintendo you can
Exactly. And so they program in enough detail to completely simulate every molecule in this universe, and we are here for their entertainment. Why else can you explain where things are going wrong just fine in the world, then all of a sudden there's a complete disruption?
The snot-nosed kid.
Culturally, politically, economically, a complete disruption. I think they throw it in for entertainment. That's what I think.
Okay, I'm going to say, I have two things to say. Firstly, I predict that you don't believe that. That's my first prediction.
Okay.
But I don't want to put thoughts in your head.
There's an argument for why that's more likely than any other scenario. I'll tell you that in a minute, but go on.
The numbers game, okay? So the idea that if you need to produce one universe capable of producing universe simulations.
And that's all you need.
And if that universe produces billions of universe simulations, then any universe that you happen to find yourself in
is more likely
to be one of the...
than the one universe that started it all.
The way that virtual reality now exists and video games have advanced, it is likely that in say 1,000 years, whatever our virtual reality would be,
30 years.
30 years. I was
1,000 or 30. Yeah.
Well, 30 years, that whatever it was would potentially be physical. Like you would be able to feel it.
Okay, so
it wouldn't. It doesn't even require that.
No,
it just requires that what you program in there in your Nintendo, whatever it is, has enough complexity that in the mind of the characters in that game, they think they're real.
Right, so
and they have free will.
It can't simulate the whole universe, because to simulate a universe perfectly, you need a computer the size of a universe.
Do you?
Do you?
Yes.
I don't know.
Because, I mean, assuming it's a perfect...
I do want to hear, but we got to take a break.
I want to hear it.
I have so much to say. So much to say.
When we come back, more of this Cosmic Queries edition on StarTalk. We're back on StarTalk. I'm Neil deGrasse Tyson. Eugene Mirman.
Hello.
Back in the house. Eugene, you tweet by what handle?
At Eugene Mirman.
At Eugene Mirman. You got it. And I've got a friend and colleague, Matt O'Dowd, who is he's an associate up at the American Museum of Natural History, my day job, where I serve as the director of the planetarium. But he's an affiliate of ours, but a professor of his own up at Lehman College.
That's right.
So welcome. And you got your own YouTube channel. I'm jealous. You got a good YouTube channel.
Well, my team's YouTube channel, I would say.
Okay, that's good.
PBS Digital Studios.
PBS Digital Studios, very good. Titled Space Time.
Exactly.
And we left off before the break, you asserting, to my disagreement, that you need a computer the size of the universe to program the universe. And I'm saying that the universe that's created doesn't have to be the whole universe. It can be just some other universe. It can be whatever less than the original universe needs to be whatever it is, where they think it's their whole universe.
That I agree with.
Okay. Good.
That I agree with.
Yeah.
We have no discussion. No.
We agree. Let's go for a beer. Right. All right.
I do have one thing to say. So
Yeah.
this whole idea recently came up. I think it got a bit of oomph because Elon Musk asserted that this was quite likely that we were part of this simulation.
By the way, just to be clear, this thought did not originate with him.
Oh, of course not.
It goes back to the 90s, and there are a few philosophers who started, who set this ball rolling, and then many others.
And one of those writers whose name I'm blanking on.
Pearl Jam?
It might have been Pearl Jam. So the idea was that we are most likely in what he called.
You got to know your groups and when they peaked. This
Yeah.
is good. This is good. This is good, Eugene.
So the idea is an ancestor simulation. The idea that some future version of ourselves, when we're more
Nick
advanced.
Bostrom is one of the original thinkers of this. I
Yeah.
think. Okay, but go on.
The idea was that in the future, scientists or kids with Nintendo would choose to simulate the entire mental life of ancestors of from hundreds of years ago, just as a study in past psychology. But that's all they have to do. They have to simulate only the activity of the mind and input all of the senses as long as they're consistent. Now that probably we'll be able to do. I mean, the brain doesn't have that many connections that we can't, in a couple of Moore's law doublings, sort that out. The problem with
By the way, I recently heard that Moore's law is now no longer 18 months. It's
How
3 years.
that's
I just heard that.
until we hit the next, I guess, iteration of once we move beyond silicon, maybe quantum
I'm just saying,
computing.
I heard it. I just
Yeah,
heard
you
it.
might be right.
By top people.
Sure.
I cannot.
This
tell you
might
who.
this might take
Very
longer
good
than-
people.
Top people.
Great.
Okay, so where are you going with this?
So the idea is it's not simulating a universe as you suggested, but I think it requires a lot of assumptions that future us will want to simulate the entire mental life of our ancestors and that we're more likely to be that. But my main objection is that part of the idea is that if something goes wrong, for example, we figure out we're part of the simulation, then whoever's running the simulation can edit it and remove that thought and business as usual.
Sure.
And so it's the most useless hypothesis.
There are people who disappear and no one knows where they are.
But that
Stuff happens in our life.
that would be. But
Yeah,
that would
we
be.
blame the Russians.
That would be.
But actually,
That would be
it's just some kid.
You've had thoughts that popped into your head today that you never had previously in your life.
So there's no way that the conspiracy can be proved or denied because everything's programmed, including evidence that we see that it is true. People disappearing, Roswell, all of this stuff is presumably programmed in. So I reject it because I think we need to continue on as though it's not true.
Well, you could do both. You could be like, well, maybe we're a simulation, but we should clearly live life as if we're people.
Yes, we have free will.
We would also still even in a simulation, if you murdered someone, you'd go to simulation jail, which I'm sure is terrible.
That's true.
Yeah.
I don't know.
All right, next question.
All right.
Big Dog D1223 asks, if Venus doesn't have a magnetic field, then how does it keep its thick atmosphere? Shouldn't it end up like Mars?
That's a good one.
I'm not a planet guy, but let me sort of address it.
Sure.
First of all, so one of the things that keeps our magnetic field stoked is that down in our sort of semi-molten iron core, you get iron sort of moving, and if you have and Earth is spinning. And so, since we spin at a relative once a day, all right, that's relatively fast, much faster than Venus.
How fast does Venus spin?
Like a little less often than once a year.
and in the wrong direction.
Right.
It spins.
What a dumb planet. You can have that as a book title.
Yeah, what a dumb. So you are fewer days old on Venus than you are years. So it's not churning. You don't get this sort of what they call differential rotation. So Venus, does not have a significant magnetic field. A magnetic field protects you from the ablative effects of the solar wind, and so there's Venus closer to the sun, getting twice the flux of solar wind than we get, and it maintains its atmosphere. So generally, when what goes on here on Earth is, it's not that it will blow away our atmosphere. It's that if there's a water molecule high up, H2O, the energy from the sun can break apart that water molecule, separate the hydrogen from it, then you lose the hydrogen. Because hydrogen is very light. And in a given temperature gas, it's the fastest moving atom. Okay, if it doesn't bind onto something, it's just going to escape. You're going to lose your hydrogen in a Earth-sized gravity. So you can systematically lose your water from such a place. And Venus, as far as we know, has no water. It's all carbon dioxide.
Well, it does
mostly
have,
carbon dioxide atmosphere.
It has hydrochloric acid up there, which I guess has some hydrogen. But I think part of it is also that Mars is much, much lighter than Venus, and so Venus is almost as massive as the Earth, and so it holds on to its atmosphere. And it has so much of it. It's got to be losing stuff, but the time scale is just much, much longer.
Right, and it's got nearly 100 times the atmospheric pressure as Earth. So,
From how does that?
well, so if you go there, you'd be crushed split seconds before you vaporized.
Is that the order?
Why is it
not the other way around?
So
I don't know the full origin of that.
Right.
No.
It's got a lot more of it.
well, I'm not going then.
I'm not a planet guy.
What's the record?
If I don't know something, I would say I don't know.
Yeah,
it,
yeah.
but-
The record for a lander on Venus is something like 2-3 hours before it crumpled in like a
Yeah,
trash can.
and the big Venus people were the Russians. They had the Venera spacecraft.
And they sent it, and they got some info, and then got crushed.
Yeah, you get crushed and it melts. They knew this, but it's still a challenge. While we were going to Mars, they were going to Venus.
Right. Did we go to Mars because it's super easy?
There you go.
It's actually hard. It's pretty.
So
Mars
easy.
is hard.
Venus is closer.
But a quick thing. So while we're on the subject, allow me to tell you the story of Venus.
Sure.
Oh, okay.
I was going to say, do you know the story of Venus?
I know the story of Venus.
Great.
So, if you're from Mars, you're a Martian. If you're from Earth, you're an Earthling. From Venus, you're a Venusian. We have these words. If you are of those places.
Yeah.
It turns out Martian is correct. Earthling is good, but Venusian, that's a improperly formed word. We're stuck with that word because the properly formed word was already taken by a whole other branch of science, the medical doctors. If you are of Venus, you are venereal.
Oh, from the Latin.
From the Latin, exactly. That is the genitive form of Venus. And so when doctors found diseases peculiar to lovemaking, and Venus being the goddess of love and beauty, they said, let's name it all after Venus.
Right.
So that became the category of venereal
And
disease.
aliens were like, we would rather you didn't call us venereal.
Right. Exactly. They're pissed off ever since. So we should not be surprised that the spacecraft the Russians sent to Venus were all called the Venera series, and it's because of that genitive form.
So war wounds should be Martian, like that's a Martian contusion you receive.
Yeah, that's if you want to be symmetric
Consistent.
about that, consistent. Yeah,
Okay.
you have a Martian wound.
Exactly.
Yeah, very bad wound.
Let's try to make that happen.
Yeah, right.
Nailtson from Syracuse in upstate New York.
You're almost as bad as Chuck Nice at this. He mangles the names every single time.
I'm not mangling anything. It's
People
not
choose
a
weird
word.
names.
I'm meaning like people's like monikers, which isn't a word.
I had a space-time commenter called well, I think I pronounced it correctly.
Yeah.
Spelled S space SS. And
Yeah.
we have an obligation. This is their
I
chosen
feel like
identity.
I read Big Dog D1223
You did
quite
justice
accurately.
to Big Dog D12223.
All right, so Nailtson, also accurate, from Syracuse asks, do scientists and theorists have any idea how much time passed before the Big Bang? Was there time before the Big Bang?
I can answer that.
Yeah, I know.
We have no freaking idea. Okay, next question. No, what do you have? What do you got for that?
I mean, the standard wisdom was always that time started at the Big Bang, and that before that there was no time. That was the first second happened then. But I think there's new thinking now. I think ideas like eternal inflation, so the idea that possibly this universe just nucleated out of some inflating, rapidly expanding multiverse type thing in which time might have some sort of existence.
Yeah, but then it would be time, there'd be a meta time for the meta universe,
Yes.
basically.
It may
Whereas
be so.
our bubble surely has a beginning point. And so,
Sure, that one dimension.
So I don't want to get semantic on it. We can
Right.
say time as we measure it began at our beginning.
Right.
But if we are part of this multiverse, then you should think of a multi-time
Right.
that actually is the master clock of all.
Yeah, or it's talk instead of chain of cause and effect. There was a cause before the Big Bang of some sort.
So like roughly an hour,
Yes, like
45 minutes.
45 minutes.
I don't want to
for
be
sure.
inaccurate. All right, Mr. Findle asks, we created tools to detect and see different wavelengths of light that our eyes can't see.
That's for damn sure.
Are there any ideas of tools that would allow us to detect and see dark matter?
so many ideas depending
Yeah.
on what on Earth
Well,
or in
first,
space that is.
we do see the effects dark matter has on matter.
Right.
Dark matter has
What's
gravity.
the effect we see? Okay.
It has gravity. That's how we know it's there. That's
See
why we talk
stars
about it at
rotating
all.
too quickly.
And I keep saying this, it shouldn't ever have been named dark matter. It should have just been called Fred. Because we don't know anything about it.
Meaning it's not matter per se.
It may be matter, maybe not.
Yeah.
So to call it any kind of matter is misleading.
Yeah,
Right.
It's
Presumptive.
presumptive.
That's a
Yeah.
better word. Thank you. But what it actually is dark gravity. That is literally true.
Yeah.
So we see its effects on things, and that's pretty good. That's why we all know something's happening out there.
Yeah.
All right. So now, is there some other way we can detect it? You got any ideas?
Depends on what it is. I mean, if it is really matter then and some kind of particle, then people are all over it. So
People are. That's the over under on that is that it's going to be a particle.
Like some ideas is that it might self-annihilate when dark matter particles find each other, and that would produce very high energy light. Or other particles that we could detect here on Earth as little flashes of gamma rays or cosmic rays.
Is dark matter something that's far out in space, or is it near the Earth, or is it everywhere? Meaning it might be in this room.
It's certainly in this room, but dark matter is so diffuse, it's manifest only on very large scales.
Exactly.
So it is so dominated by ordinary matter in normal situations. It's this, you can live life as though it's not there.
Right.
Same with our solar system. You don't need to invoke dark matter to calculate anything that's going on anywhere around us.
But in deeper space where there's less, it has
and bigger space.
There's more space, and so
Yeah.
it just adds up over
over
the light years.
And here's the thing: might we ever find if it is a particle, might we ever find a dark matter planet or dark matter something else? Probably not, because not only does this dark matter stuff, Fred, not interact with us, ordinary matter, it doesn't even interact with itself. And if you don't interact with yourself, you cannot coalesce and become something.
How do we know it doesn't interact with itself?
Because it would otherwise stick to itself.
There are ideas that would allow it to
Hang out near each other?
to annihilate itself when they interact, but it's so small and spread out that it just doesn't happen very often
You think it's only a frequency issue?
by some models.
Okay.
But or it might not interact with itself.
Okay.
That's also possible.
Right, because our particles, we make molecular bonds, atomic bonds.
Yeah,
These
so
sorts of things.
it's not going to stick.
So we
to
make
you.
molecules, and then we can be this fleshy thing called humans.
Yeah.
It's not capable of that sort of
Right, it's not.
complexity.
Yeah. But it'd be really cool if they were like humanoid dark matter entities. That would be cool.
I like the whole idea
Yeah.
of a
They'd be
dark.
completely transparent because they don't interact with light.
They could be right here, right now.
They could be walking among
They could
us.
be all around us?
Yes.
Oh, maybe that's what angels are. Okay.
Solve that.
Yep.
One more, real quick. What do you got?
Great.
Before we break.
Someone let Mike Huckabee know. Justin Kenna on Instagram asks, is it possible for the fabric of space to be ripped or pulled apart? Could an overexpanded black hole then be the cause of a sort of Big Bang as the matter rips a hole through the fabric of space?
I saw that episode of Doctor Who, by the way. No, so I love the idea that we might rip. It's terrifying and beautiful at the same time. We're not going to rip in what we're doing now, but in the distant future, where this dark energy pressure of the vacuum is forcing an
Also
acceleration.
poorly named, by the way.
An acceleration of the expansion. That will grow exponentially. So I'm curious, might there be a day where space is expanding so rapidly that its pliability cannot keep up with what's happening to it, and it just rips instead of continues to stretch?
Or at the very least, atomic nuclei are ripped apart and yeah. So if that's your favorite cosmic destruction,
It would be terrifying, but oh my gosh, that'd be a new thing.
I think even cooler is vacuum decay.
Ooh,
So the idea,
vacuum decay. Do you want? Oh,
What's vacuum decay?
oh, it's terrible.
vacuum decay is great.
Over the
Well,
commercial.
decide if it's
And,
great.
and
You tell me what
it could happen anytime.
Over the commercial, he'll tell you.
Okay.
When we come back, more of Star Talks, Cosmic Queries, Potpourri Edition. Neil deGrasse Tyson back at you. StarTalk. Cosmic Queries Edition. Potpourri. Grab bag. I got Eugene Mirman. Eugene.
Hello.
Love having you. Don't stay
being
away
here.
for so long next time.
I'll be back soon.
Yeah, call me or something. I
will.
Right, okay. Matt, great to have you.
Hey, guys.
We're at the YouTube studios. Why? Because you have a YouTube show
Sure, I do.
called Spacetime. Great name.
Thank you very much.
And it's the PBS,
Good name.
I didn't come up with
No,
it,
great.
but yeah.
PBS Digital Studios.
That's right.
Very good. And so we're doing Q&A here, and something that keeps me awake at night is wondering whether the vacuum energy of the universe is stable.
I have
you
lost
thought
sleep.
about-
I have lost sleep.
You've lost sleep too?
Last night I
How
lost
about
some
you?
sleep.
Have you?
I'm about to.
We're going to make sure you join the club.
Yeah. What is it?
So vacuum decay.
Yes.
It's scarier than the big rip that might happen due to dark energy because it could happen at any time. It could happen spontaneously. So the idea is that the vacuum, it basically a vacuum means there's nothing in it. Mm-hmm. But actually the vacuum has some tiny bit of energy. The fields that permeate the universe that give rise to particles are through the vacuum. Now, one of those fields is the Higgs field. Mm-hmm. Okay, it's what gives subatomic particles mass. The famous Higgs boson.
Yeah,
It's a badass
Yeah,
particle.
it's a
If you had to be a particle,
That's the one you'd
that's
be.
the
Yeah.
one you want
The
to be.
God particle.
The God
Got a good
particle.
nickname. We've got the
Yeah.
best nickname. So the idea is that
Well, can I
Higgs
give
field.
a quick explanation for how it gives mass? I
Sure.
think this explanation works.
Okay.
Okay. Think of a party in Los Angeles,
Okay.
in Hollywood.
I've never been
Sure.
invited to one, but
Okay. All right. And so, what the Higgs field does is it will create a resistance to your ability to move through that field, depending on what kind of particle you are. And the greater is that resistance, the more you measure its mass to be. Okay? Because massive things don't move quickly. So you go to a party in Los Angeles, and somebody nobody has heard of walks in. Okay? Arnold Schmednick. Okay? Fine. Walks in. No one crowds around him. He can go straight to the bar. He has very low party mass. Beyonce walks in. Then a scrum builds around her. She cannot move because people are taking selfies, getting autographs, asking her questions, paparazzi. She moves 5 inches a minute. Takes her a half hour to get across the thing. She has very high party mass. The party field granted her more mass than Arnold Schmednick.
so Arnold is a neutrino and Beyonce is
It's a massive particle.
tau electron.
Exactly. Yeah. Okay. Good.
So the universe is.
I get your approval on that analogy?
I think it's good.
you
I think it's a
approve.
great start. And I direct everyone to an episode on Spacetime we did on this subject that takes it only a tiny little bit further. Just
Okay. All right. Good.
that's
Good.
but the cool thing about the
I think
Higgs
you
field.
just dissed my example.
No, I love
No,
this.
I think
Well, here's what I
Only because I've never been invited to that party, and I know that I passed through. I know.
Tell me about the vacuum that I need to be afraid of,
Okay.
please.
So the Higgs field works because it has a non-zero energy everywhere. There's a little bit of Higgsiness everywhere in the universe.
Yeah.
This little field that goes through
That's what
all
I tell
volume of
people, and
space.
that's how I describe it.
Right. Yeah.
And just to be clear, because in case anyone who's watching this is really young, and the only concept of a vacuum is a machine that's sitting in the closet.
Right.
So that machine creates a vacuum, hence we call them vacuums, right? So in space, unlike, who was it that said it? Nature abhors a vacuum. Only on the surface of the Earth. Most of the universe is vacuum. So the universe loves itself some vacuum. Okay, so
It's a region where there's nothing, except there isn't nothing. There's some little Higgs energy.
Higgs energy, go on.
Right. And so when the universe was settling down soon after the Big Bang, that Higgs energy found a nice, comfortable place to be, a
rest.
value to take, and you can sort of think of it as it was falling downhill in energy, and it found a nice dip in the energy that it could be, and came to rest at that particular energy. But over that little hump, there may be a deeper drop and a much more preferential, comfortable, lower energy for the Higgs field to take. The vacuum, if it could get to that lower energy point, it would go there, because one thing the universe does love to do is be in a low energy state. That's something it will do whenever it can. But it needs to realize that over that little hump, that low energy state is there. It only takes one little part of the universe to get the message that it can have a lower Higgs
and
state.
it takes the whole rest of the universe with it.
Yeah, and so the idea is you have this vacuum decay. That little part of the vacuum decays to that lower energy state, and all of physics goes out the window. Everything loses mass. All particles can suddenly move at the speed of light. Time winks out as we understand it. We will become essentially photons.
Maybe say it.
Dogs and cats start dating one another.
If they don't turn into puddles first.
That is highly hypothetical. No one has
Wait,
proven
so say
that.
it again. What happens?
Oh, let me try now.
So-
can I try now?
Yeah.
I was going to do the expanding bubble, but go.
Okay, no, do the expanding one. Go.
So once the universe realizes that it is this new energy state and not what we thought, that bubble expands and at the speed of light envelops the universe.
Okay.
But the universe is big, so it might.
So it
take a
depends
while.
where it starts. So maybe it's already started somewhere.
Oh, so it only moves at the speed of light when this happens.
Yes.
Unless a tunnel's there, then the whole thing happens instantaneously.
I don't.
Yeah,
Could this
tunneling
already
is
be happening
Tunneling
somewhere?
is instantaneous.
But the distance is limited. Tunneling distance is a function of probability. So
Okay.
Yeah.
But if this is happening somewhere in the universe, then we'll just get swallowed up in it?
Yeah, basically.
Yeah.
So
Yeah.
what are the chances it's already happening?
the chances we have no idea.
By the way, I think of
Great.
this loss of the vacuum state every time I fly over Crater Lake. You know, it's the volcanic caldera, and there's a crater there.
Sure.
And there's a lake in it. There's water just sitting there.
Yeah, ready to
And
kill you.
Now, if that water knew that it had access to the ocean below, it would go like that. But it doesn't know. It's
exactly.
trapped
Yes,
in this.
that's good.
In this. It thinks it has reached the low ground because water always finds the lowest spot. It thinks it has reached the low ground, but it doesn't know that it can get lower. And so like I said, I lose sleep wondering.
And part of the problem is that because the new vacuum expands at the speed of light, we can't see it coming because light can't outpace it. The first
It can't outpace
indication
itself.
we get would be it.
It's too
arriving.
late.
So
Right.
it sounds like there, in a sense, is nothing to fear because it'll just happen.
That's not going to help me.
Well, meaning, I think a thing to fear
Right, you
is
can't
like,
even watch it happen.
Yeah,
That's the
it'll
thing.
just be we'll have been a thing and then not a thing. That's not so bad.
Yeah.
Yeah.
I mean, I don't
Yeah.
prefer it.
But we're a simulation anyway, so
Exactly.
Yeah,
gonna
but
take
one
some-
that we really love being in.
All right, what else you got?
All right. Let's
Questions from the internet.
yes.
Mhm.
Let's read this question. Ready? D61636 on Instagram asks, how was the Phoenix cluster discovered and why hasn't it devoured our solar system?
ooh, okay. I hope you know the answer to this.
No, I don't know what the Phoenix cluster is.
Well,
is it?
I guess that's another thing to fear.
No, I don't know what the Phoenix cluster is. You don't know what the Phoenix cluster
I know what the Phoenix Nebula is.
Oh, what is
that? It's a rather beautiful star-forming nebula that I guess it's some hundreds of light years away. It's quite pretty. But
Looks like a
It's
Phoenix.
nice. If it hears you say that, I think it will like it.
Yeah.
All right, here's another question. Evo Lucas asks.
Wait. Let me back up for a minute. So, I don't know if this answers that specific question, but it relates to it.
Sure.
If a black hole shows up somewhere, it doesn't automatically become some kind of huge vacuum sucking up everything that it didn't previously suck in before, given the mass that it once was. So black holes are not giant sucking machines.
Oh.
If the sun became a black hole, all the planets won't all of a sudden just get sucked into the sun.
But we would be harmed.
Well, it would be cold.
It'd be very cold.
That's the only change.
like super cold.
it would
super
be
cold.
as cold as it gets.
Yeah.
As cold as is possible.
So is this how we reassure people after the vacuum decay thing? That
Now I get why people are afraid of science. The more you know, the more there is to fear.
So if in this cluster there's some black hole they might have read about, I haven't gotten the latest on that, but if that's the case, you needn't fear freshly formed black holes.
Great.
Because the gravity, the reason why black holes are scary is because you can get very close to them, because they're very small. And when you get close to them, you feel extraordinary gravitational effects on you. If you maintain the distance you've always had from that object, it makes no difference to you.
Like if a black hole was in Chicago, would we be fine here in New York?
how big is the black hole?
Yeah, it depends how big the
The
black hole.
size of a nice shoes.
In yeah.
Yeah, it would systematically eat the Earth.
Yeah,
okay.
that would be like the mass of Jupiter. I'm
so-
guessing.
Yeah.
So
Yeah, 'cause
what
Earth
if it
is
was the
that
size
big.
of a dime?
Yeah,
Jupiter's about
exactly.
like
So what if it was the size of a dime? Would that destroy the Earth?
That would be the mass of more than the Earth. I
No,
thought
Earth is a black hole the size of like
it's
a grape.
it's 9 millimeters in diameter.
yeah.
So a pomegranate seed black hole, what would that
He's
do?
still going
moon,
with food.
That sounds rough too. The types of black hole that the Large Hadron Collider would produce in its when it collides beams, those would be so infinitesimally small that it shouldn't be a problem. They should decay instantly.
Very
for one thing.
reassured. How reassuring. So the thing, so
You
basically,
should be okay.
Basically, if
You'll
it's something,
probably be okay.
if it's edible, if a black hole was the size of something edible, we would all be dead.
Yeah, exactly.
Yeah, it fits in your mouth.
I did think of a way to be scared
Systematically, I
of
mean,
the
have
Phoenix.
to eat all the Earth in its vicinity. You would systematically.
bigger.
But how long? Oh, and so like, but it would be minutes or seconds.
Fractions of a second, I would guess.
Oh, again, not so bad.
Speed of light.
But we'll have to do the calculation, I think.
Yeah,
and come
yeah,
back to it.
but quickly.
Oh, good.
Yeah,
Time for another
Yeah,
question.
let's do it.
Great. Vojta. Oh, no, wait. We never read Evolucus. When it comes to the multiverse theory, is there any way to know the ages of the various universes, or would they all be the same age?
Wow. So I think the answer is absolutely no way, given that there's no way to test whether they exist.
So here's an interesting fact of science. Generally, if you don't know anything, your first question is the simplest. Does it exist?
Right.
Then when you confirm that it exists, then you ask the next round of questions. How long has it existed?
Right.
Will it die? And then you go, how big is it? What are the properties? So right now, we don't even know if multiverses exist,
Right.
much less start handing out ages to them. The idea is these things pop in and out of existence forever in some meta clock.
Right.
All right. And yeah. So
How would you know if there was another universe?
Well, it also depends on the type of multiverse. I mean, there are many different types to choose from.
What's example, like five
So
examples?
5 examples, easy.
2 examples.
Easy. Let me write. So there's the quantum multiverse, the idea of many worlds that the universe splits into to multiple realizations of itself at every little subatomic decision. That one is the same. They're all the same age because they all started from the same branching chain. Then you have the.
this is the famous many worlds
Exactly,
interpretation
yeah.
that came out of the physicists in Denmark. So they called it the Copenhagen Interpretation.
It's post Copenhagen.
Copenhagen.
Yeah, it makes the same predictions as Copenhagen. But this came out in the 60s, and I'm blanking on the physicist's name.
Who's that? Okay. Mhm.
Anyway, so then you have the idea of the multiverse that expands from what I mentioned earlier in the show, the eternally inflating multiverse. So one part of it just stops inflating so crazily fast and just does regular Big Bang inflation, and those should just be appearing all the time in that greater multiverse. One cool thing about those is that it may be possible to detect them if you happen to have two universes that kind of appeared like champagne bubbles and overlapped in the very beginning,
Intersected.
and merged. You would see like rings on the cosmic microwave background radiation, sort of coffee stains of where they interacted back in the beginning. And we haven't seen them yet, but we will keep looking.
Coffee-stained universe. Somebody's a poet.
There's another one where the actual space-time that you're in has pockets of non-causally connected expanding sections. So in other words, we look out to our horizon, but beyond that horizon, there's a whole other universe, but part of our space-time, but we don't have access to it. And so that there's this huge fabric of space-time and just universes dotting the space within it. And so...
And that type should be they all should be the same age.
Exactly.
They started with the same Big Bang.
Exactly, that would be the same Big Bang that birthed it.
That's
Right.
3.
But my favorite one is the one where it's just this frothy foam that is birthing universes back and forth.
And just for completeness, number 5, the fecund universe of Lee Smolin, where black holes, when they form, they create new universes.
Because inside of a black hole, the mathematics tells you a whole other space-time emerges.
On the other side.
Because you fall in, you'll get to that after you see the future history of the universe from whence you came unfold.
No.
Yeah. So yeah, that
I got shivers just then.
Yeah. So the answer is we don't know, but some of our ideas are really great.
we got to stop it here. You've been watching, if you've seen this on YouTube, or otherwise listening to StarTalk, a Cosmic Queries edition. I've been your host, Neil deGrasse Tyson, your personal astrophysicist. I think Eugene Mirman. Eugene, thanks for coming back.
Thy you very
Call
much for
me
having
sometime.
me. I will.
All right, you're in
I will.
Boston
I'm
now.
going to start texting you science questions in the middle of the night.
Then I know you are alive. You're going to say, you up?
Yeah, exactly.
There you go.
I will.
At 2
Be like,
o'clock
how
in the
does the universe work, Neil? I'm at a bar with some friends. We want to know.
Exactly,
I've got that.
exactly. And I think my friend and colleague, Matt O'Dowd, who's got his own YouTube channel on PBS Digital Studios, and it's called
Space-time.
Space-Time. If I type in space-time, it goes to you.
Type it straight into.
It doesn't go to Einstein's theory, it goes to you.
We're number 3 or something like that. Or you go straight to YouTube and type
Okay,
it in.
work harder. You might become number 1 on
the
that.
aim.
Great having you. Thanks for
thanks a lot.
for being
It was
on.
really fun.
All right, good. So as always, I bid you to keep looking up. This is StarTalk.